Welcome guys to my new video. In this video I want to talk about the John von Neumann architecture. So first of all, like my video, subscribe to my channel, and let's start our course. Now let's talk about the John von Neumann architecture. What is the John von Neumann architecture? The von Neumann architecture is a standard architecture that can be found in our computer today. It was invented by the mathematician John von Neumann and represents a major milestone in the history of computing. It is based on the fundamental concept that data and programs should be stored in the same memory, meaning a shared memory that contains both code and data. At the end of 1945, John von Neumann proposed the stored program concept and the construction of the electronic discrete variable automatic computer as a model machine of the computer. The electronic discrete variable automatic computer was a binary computer rather than decimal and was stored program computer. Finally, John von Neumann proposed to store both program and data together in one memory. This is the architecture of the John von Neumann. This is the architecture of the John von Neumann and how it works. The program is a sequence of instructions provided to the computer for an eventual execution by the processor. The processor here, it contains the control unit and the arithmetic logical unit. The role of the processor is to extract the instructions from the memory one by one, to interpret them and to execute them until the problem is solved. The instructions transferred is made through bus. First, let's talk about the arithmetic logical unit. ALU is a logic unit. It performs mathematical operation like the addition, multiplication, the division, and logic operation, for example, equal and or not equal, for example, requested by the program. The control unit, CU, it interprets the instructions in memory and causes them to be executed. The memory, it stores both data, variables, and program, and the input-output operator, it allows the computer to communicate and interact with the outside. For example, the keyboard, I enter the data by the keyboard. It's an input. Output, the computer print the data on the screen, for example. The keyboard and mouse is input variable and the screen is an output. This is how the John von Neumann architecture works. Now let's go to talk about the arithmetic logical unit, LAU. The arithmetic logical and logic operator unit, LAU, is a component of a computer that is responsible for performing basic operations. These operations include arithmetic operation like the addition, multiplication, and division, as well as logic operator. For example, a calculator is capable for performing an arithmetic and logical operator. The ALU is like a calculator for a computer, as it can carry out the necessary arithmetic and logical operations to execute a program. This is what the arithmetic logic unit it's important for the computer. It's like a calculator for the computer. The ALU is the computer unit that is responsible for performing calculations. It is integrated into the CPU. It means the microprocessor. Now the control unit, or CU. Control unit determine the order in which the instructions of a program should be executed and control the retrieval of the proper operands. It governs the flow information through the system by issuing control signals to different components. The control unit is a component of a computer responsible for the sequencing of operations. The CU is in charge of reading instructions from the currently executing program and transmitting this instruction to other computer components. The control unit operates by following a set of predefined instructions known as sequencer. The sequencer is a table that instructs the CU on which instruction should be executed at each step of the program. The CU also uses an instruction register to store the instruction currently being executed, which contains the memory address of the instruction. The CU is an essential component of any computer. Without the CU, the other computer components should not be able to function in coordinated manner. This is the architecture of the control unit and how it works. In the CPU, it gives the command to the ALU, and the ALU gives the result to the memory, and the memory gives the data to the arithmetic logical unit. The control unit gives the command to the memory, and the memory gives the instructions to the control unit. This is how it works, and this is what is the control unit in our program. Now let's talk about the important part of our computer, the CPU. The CPU is the abbreviation of the Central Processing Unit, commonly called processor. The CPU is the brain of the computer where most calculations take place. This is the CPU that can be found in our computer. It is the unit that performs the program processing stored in the main memory inside the computer. CPU has two components, the arithmetic logical unit ALU, which performs arithmetic and logic operator, and the control unit, which extracts instructions from memory and execute them, calling on the ALU when necessary. The processor has two components, the arithmetic and logical operator and the control unit. The CPU also contains very fast and small memories called registers. A register may hold an instruction, a storage address, any kind of data, or temporary result. This is the importance of the CPU in our computer, and this is what is the CPU. It's a very important processor in our computer. Without CPU, the computer doesn't work because the CPU is the brain of our computer. Now let's go talk about the diagram detailing the different elements of the John von Neumann architecture. This is the diagram of the John von Neumann architecture. We have here the central process unit. In the central process unit, we have the control unit, arithmetic logical unit, and the register. And here we have the memory unit. Here we have the input device and the output device. In the register, we have the PC, CIR, AC, MAR, and MDR. Now let's see what is the AC. AC is the accumulator, is a temporary memory used to store data during processing in the computer, stores intermediate arithmetic and logical results. The PC or the program counter keep track of the memory address of the next instruction to be executed. It essentially points to the location in the memory where the CPU should fetch the next instruction. MAR or the memory address holds the address of the memory location to read from or write to in our computer's memory. CIR, current instruction register, holds the currently executing instruction in a computer center processing unit CPU. The MDR, or the memory data register, temporarily stores data fetched from or to be written to the computer's memory. This is the different part of the registers in the CPU. The memory is a component of a computer responsible for storing data and programs. Data consists of raw information such as numbers, letter, image, music, audio, etc. Programs are sets of instructions that guide the computer on how to perform tasks. The RAM, the memory has two types. We have the RAM, or the random access memory, and ROM, the read-only memory. The RAM in the computer working memory used to store data and performs currently is used. The RAM is a volatile memory, meaning it loses its contents when the computer is powered off. But the ROM in the computer performs memory. It's the permanent memory, stores programs necessary for the computer's startup and operation. This is the difference between the RAM and ROM. The memory is a component of a computer responsible for storing data and programs. We have two types of memory: random access memory RAM and read-only memory ROM. Now let's talk about the main memory, or the RAM. This is the RAM. You can find this also in our computer, laptops, and etc. The main memory RAM, or the main memory, is called random access memory. The area in the computer that stores programs and data of quick access by the processor, the CPU. In addition, it can manipulate only data that is main memory. Therefore, every program you execute must be copied from a storage device into the main memory. Everything in the memory is stored in binary. The computer works in the binary 0 and 1. The RAM is a volatile memory, meaning it loses its contents when the computer is powered off. This is all the definition about the RAM and what is the important about the RAM. Now let's go talk about the ROM, or the read-only memory. Is a non-volatile memory, which means it retains its content even when the computer is turned off. The RAM, the content it loses when I turned off the laptop. As for the memory that contains both data and the currently running program, it's known as random access memory. RAM is used to store the data and the program currently is executed. Now the bus. In computer architecture, a computer bus is a communication system that transfers data between components inside a computer. A bus consists of a set of wires that carry binary signals. There are three types of a bus: a data bus for the data transfer, the address bus for the address transfer, and a control bus to the control signal transfer, such as read from the memory. This is the bus and the importance of the bus in our computer. Now the input and output unit. The input and output unit are devices that allow the computer system to communicate and interact with the outside world and to store information. Let's start with the input unit. It brings information into the computer that will be coded and later on processed by the CPU. For example, of the input unit, we have the keyboard, mouse, scanner, webcam, microphone, camera, touchpad, pen, the input, electronic whiteboard, the card reader, the CD, sensor, and etc. But the output unit are devices that bring information out of a computer after being processed. For example, we have the monitor, printer, screen, speaker, and the LCD projection panels. Some devices called input-output devices provide both input and output of data such as a hard disk, the pads, modem, touch screen, audio sound card, and the network card. This is the difference between the input and output units in our program. And now let's talk about the hard disk, HDD. This is the hard disk, can be found in our computer also. The hard disk is an electronic data storage device that is used magnetic storage to store and related digital information using one or more rigid repeatedly rotation disks or plater coated with a magnetic metal. The platers are paired with the magnetic heads, usually arranged on a moving actuator, which read and write data to the plater surface. Data is accessed in random access manner, meaning that individual blocks of data can be stored. The HDD are a type of non-volatile storage, retaining stored data even when the power off. This is all about the hard disk, the HDD, and the importance of the HDD in our computer. Now let's solve this exercise. What John von Neumann does in computer science. John von Neumann made significant contributions to computer science by developing the architecture of the modern computer, known as the John von Neumann architecture. This framework outlines a system where data and instructions are stored in the same memory space. He also attributed to the development of game theory and cellular automata, foundational concepts in computational theory. He make a memory that contains the code and the data in the same time. This is what the John von Neumann does work in computer science. And exercise 2, what is the difference between the ROM and the RAM? Write me the answer in the comment section, and this is all for today. Thank you for watching, and see you in next video.